So we want to talk a little bit about overtones and fundamental frequencies and how we can use these concepts inside of solving problems. So we know that there are overtones and that overtones are always related to the fundamental frequency, which we can describe as being f sub 1. That's the first frequency that we use to get a resonance, f1. And any overtone that we're going to get is going to be related to f sub 1. It's going to be some multiple of f sub 1. So we can call it n times f sub 1 would give me the n minus 1th overtone. So what does that mean? That means if I plug in n is equal to 2. So I do twice the fundamental frequency. That's actually going to be the 2 minus 1th overtone. 2 minus 1 is equal to 1, so that's the first overtone. It's the first tone above the fundamental frequency that gives you a resonance. Then we also know that, for example, n equals 3. If n equals 3, I can do 3 times f sub 1 to get another overtone, and that would be 3 minus 1th overtone, which would be the second overtone. It's the second frequency above the fundamental frequency that will give you resonance, that will make your frequency sound louder than it actually is, that will enhance your sound. So how can we use this concept inside of this problem? Well, this problem where we're given two actual frequencies. We're given a frequency, we'll call it f sub n, some overtone. We don't know what it is, we don't know what n is, but it's equal to 440 hertz. And we also know that there's another fundamental frequency, another overtone that resonates. We're going to call this f sub n plus 1. So this is the n plus 1th overtone. And we know that these overtones immediately follow each other. So this is going to be maybe the third overtone, and this would be the fourth overtone, because there's no overtones in between. And what we can do is we can use this to write out an equation based on this general form that we have here. We know that overtones are equal to n times f sub 1. So let's shrink this down and move it over, and let's write out an equation. We know that we can take the f sub n plus 1 frequency, and that gives us an overtone of n plus 1. That's the number of the overtone times f sub 1. That is the definition of this overtone based on this equation right here. We also know that f sub n, the nth overtone, is equal to n times f sub 1. All the overtones are again related to some multiple of the fundamental overtone. So I know that one of these guys is going to be f sub n. We've established that. And I know that one of them is going to be f sub n plus 1. And I can do some stuff with this. I can figure out the difference of these. These are just two numbers, so I can subtract these two numbers. I can do f sub n plus 1 minus f sub n. That would be equal to 660 minus 440. And that's going to give me a value of 220. Well, how does that help me? Well, if I plug in my general values, my general equations for f sub n plus 1 and f sub n. F sub n plus 1 is n plus 1 times the fundamental frequency. And then f sub n is equal to n times f sub 1. Again, these are just plugging in for f sub 1, my n plus 1 times the fundamental frequency, and for f sub n, plugging in my n times f1. These are the same exact equations. These two guys are the same. So let's distribute this f sub 1 into the both elements that are in the parentheses. So I have n times f sub 1 plus f sub 1 minus n times f sub 1. And when I solve this out, my n times f sub 1's cancel out, and I'm left with just f sub 1. And since these two equations are exactly the same, that means that my f sub 1 has to be equal to 220. So my fundamental frequency for this problem is 220. And then which overtones am I actually working with? I need to figure out how I can multiply n times f sub 1 to give me 440. That was my n plus 1, my nth overtone. And then I can do n plus 1 times f sub 1 to give me 660. So if I know f sub 1, I can plug that in. I do n times 220 is going to give me 440. And I just do the algebra to solve this out and find that n is equal to 2. So that means this first frequency is going to be equal to the first overtone. Because remember, the number of the overtone is the integer n minus 1th overtone. And you can go back and re-watch that in this little short video. Then we can check the other one. We can check n plus 1 times f sub 1, which is now 220. We can plug that in so we can figure out what this next overtone is going to be, equals 660. So we do divide both sides by 220 and solve this for n, and we again find n is equal to 2. That shouldn't come as a surprise. We already found that in the previous, using the previous overtone, and then I know that this f sub n plus 1 is going to be the 2 plus 1. Again, subtract off that 1 to find out which number of the overtone it is. And we get 2 plus 1 minus 1 equals the second overtone, which shouldn't surprise us one bit.